Okay, in lesson 4.4, we are going to focus on creating parallel and perpendicular lines. So we're going to do three major, bullet points, if you will, for each of these. We're going to define what parallel means and what perpendicular means. We're going to talk about the relationship in the slopes and how it is special between the parallel slopes and perpendicular slopes. And then lastly, we're going to be able to write lines that guarantee parallelness or perpendicularity to another line. So being given a line, you'll be able to create another line that guarantees certain characteristics, including parallel and perpendicular. So we're going to start off with parallel lines first, and we'll begin by defining these. So two lines in the same plane, that's pretty important, that never intersect are parallel. This same plane concept will become a lot more important when you get to geometry next year. This year, everything we'll do will be on the same plane, so that's kind of a standard for us right now. But it is important to point out that in geometry, you'll notice that there's some other scenarios where this is different. But two lines, if they're on the same surface or the same plane, on the same coordinate grid, if you will, like the ones pictured below, then if they don't ever intersect, that's what we call parallel lines. Okay. Non-vertical lines are parallel if and only if they have the same slope. So this is at the essence of how you create this, right? So if they're not vertical, because of course those always have to be, the verticals will always have kind of their own little subgroup because they're special. They'll be parallel if and only if they have the same slope, and I'd like to point out here, but different y-intercepts. Different y-intercepts. So graphically, what that really means, and you have a couple of examples here, right, is that their steepness is exactly the same, but they're located in different places. So the same slope gives us the exact same steepness of the line. The different slopes gives us different locations. And so that creates two lines that have exactly the same steepness, and therefore they're never going to intersect each other. Okay, and then of course we've got to talk about the special cases, right? So all vertical lines are parallel to one another, and all horizontal lines are parallel to one another. Okay, when we talk about lines being parallel, we can use a symbol to kind of shorten our work a little bit. So the symbol for parallel lines is two sort of long straight bars like this, and you'll see me use it a lot when I'm comparing lines to say that they're parallel. Okay, all right, so let's start with graphs. We just want to determine if any of these lines are parallel, and the way that we're going to do that, and this is the big idea here, is compare the slopes. Because really, when I have lines in front of me, this is what I'm going to be checking for, that they have the same slope but different y-intercepts. So we're going to compare the slope. And from a graph, that's pretty easy to do. We're just going to check out what that rise over run is, just as a reminder, and see if it's the same for all of the lines. So on number one, I have three lines. What I want to do is find the slope of each and then see if any of them have that same slope. It's obviously already, they're not the same line. They're all in different locations, so that's a good start. So if I talk here about the slope of line A, so line A has 2 points here, and I can just go from one to the next and use that as my rise and my run. So it looks like I have a rise of 3 and a run of 1, so that is 3 over 1, or just 3. Okay, now let's compare that to the slope of for line B. I have 2 points. I'll compare the rise over run ratio and see if it's the same. But for this one, I rise a total of 4 units up and 1 over. So that's 4 over 1, or a slope of 4. Okay. For line C, I have 2 points again. I'm going to check out this rise over run. And it looks like when I go up 4 units over 1 for my slope here. It would also be 4 over 1 or 4. So now that I've determined the slope of each of those lines, I notice that 2 of those lines have the exact same slope, and therefore there would be the ones that are parallel. B and C are parallel, and I would want to state that using my little symbol here. That's how I would write that. I would say line B is parallel to line C. Okay. Try number 2, and then you can check your answer in just a moment. Okay, so check your slopes. If you tested the slope for line A here from one point to the other, I personally got a rise of -4 over a run of 2. I know there's a lot going on there. For the next one, for B, from one point to the next, I got a rise of -2.5 over 1. And for C, I got a slope of down 2 units and over 1 unit. And so these were our slopes for the 3 lines. 2 of those have the same slope. So line A is parallel to line C. And we can use, like I said, we can say that pretty quickly with our symbol for parallel lines. Okay, so if they have the same slope, and then making sure just that they have different y-intercepts there, that guarantees parallel lines. Okay, now that's from a graph. That's nice and easy. Let's check it out from 2 points, right? Well, it's really still all about the slope. So if instead of a graph, what we'll have in front of me is 2 points, then we will, in this case, use the slope formula. So for graphs, we compared the rise over run in the graph. For these, we are going to use slope formula, since what we have is 2 points, right? We just work with what we have. So just a reminder that the slope formula is at y2 minus y1 over x2 minus x1. It's the change in y over the change in x. And then we can find the slopes that way and compare them. Okay, so let's try this next one. Then we will, so for line A, we're going to do the change in our y. So it's 2 minus a -1 is 2 plus 1. And then 2 minus a -4 is 2 plus 4. So that is 3 over 6, or in other words, 1/2. So we can still find the slope from the 2 points using the slope formula, even though we don't have a graph in front of us. Okay, for line B, 5 minus a -3, sorry, not 1 minus a -3 is 1 plus 3, and 5 minus a -5 is 5 plus 5, so that's 4 over 10, or in other words, 2/5. So those are definitely not parallel because they have different slopes. And then for line C, -1 minus a negative, it's -1 plus 3, and 2 minus a -2 is 2 plus 2, and that gives us 2 over 4, which simplifies to 1/2. So do I have any slopes that are the same? I do, line A and line C. So I can say that line A is parallel to line C, and there's our answer. Okay, so pause it, try this one on your own, and we'll check it in a moment. So on this one line had a slope of -1, the other line had a slope of 1 over 7, and the third line had a slope of -2. None of these were the same slope, so none of these lines are parallel. And that will sometimes happen, right? So none of these guys are parallel. Okay, so we know how to do it from a graph. We check the rise over run from the graph, we find those slopes, and then we decide. From 2 points, we'll use the slope formula. For an equation, okay, we'll use What's the easiest way from an equation to see the slope? Is to be in slope-intercept. So we're going to use y equals mx plus b. Okay, if it's not already in that format, then remember, all you have to do is solve for the y value so you can get it into that format. And then we'll check to make sure the slopes are matching and the different, and then we'll be able to decide, oh yeah, those are parallel. So that's what we're going to be checking for. Okay, so for this one, I'm going to do it in pencil because, you know, work and math. Pencil's good. So we'll put it in slope-intercept. Let's start with line A. Y is not isolated, so that's going to be my first goal. So I'm going to write our equation down. It's 4x equals negative 3y plus 9. And I want to get y by itself. So I'm going to move the 9 to the other side. So now I've got the 4x with a negative 9 over here. And then the other thing I need to do is get rid of that coefficient in front of the y. So I'll divide everything by a negative 3. Everybody. Okay? And so that gives us a negative 4/3 x, a positive 3, and then just the y value by itself on the other side. Okay, so I've got the y isolated. This isn't y equals mx plus b, even though the y is on the right. That's okay. But we can see right here that our slope, the slope for line A, is a negative 4/3. Okay, and then we'll do the same for the other two lines and decide if any of them have the same slope. So I'm going to make myself a little barrier here. Let's work with line B. So line B is 8y is equal to negative 6x plus 16. That was pretty close to being isolated. All I have to do is get rid of the 8. So I'll just divide everything by 8 to get y alone. And when we do that, we get a slope here of negative 6/8, which I know simplifies to 3/4. So that's a negative 3/4x. And then our y-intercept is 2. And now we can look at this and identify that the slope of the B line, or the line B, is a negative 3/4. Okay? And then we'll do same thing with this last one. Here's our last line. It's 4y equals negative 3x plus 9. We want to get y by itself, so we'll divide everybody by 4. When we do that, we get y equals negative 3/4 is just negative 3/4x. And then the 9/4, that's just our y-intercept. I'm going to leave it like that because what I really care about is comparing this slope, which is a negative 3/4. So do any of our lines have the same slope? Well, yeah, these two, right? B and C. And then I just to make sure, oh yeah, and they don't have the same y-intercept, so they're definitely not the same line. And here I can go ahead and conclude that line B is parallel to line C. Okay, try number 6 and check it. Okay, so check your slopes. If you got 1/5 for the slope of line A, 1/5 for the slope of line B, and 2/5 for the slope of line C, then you are in good shape, right? It was a matter of manipulating it, getting into slope-intercept form, and being able to, pluck out that slope and find out what it is. So which of our lines, if any, are parallel? Well, these guys have the same slope. Check to make sure they also don't have the same y-intercept, because then they would be right on top of each other. But they're not, so we're good. As long as they have the same slope but different y-intercept, you've got parallel lines. So here on number 6, we could say that line A is parallel to line B, and that would be our answer. Okay, so we've done it all kinds of ways now. Graphs, from 2 points, from equations. Let's talk about writing the slope of a line that is parallel. So it says here, write the equation of a line that passes through the given point. So we want our line to pass through the point 1, negative 6. So we're going to want to make sure we guarantee that it passes through this point. But we want it to be parallel to this other line, okay? So this line's already established. We're going to create our own new line, but we want it to have some specific characteristics. We want our line to be parallel to this one. So how do we guarantee that? We just talked about that up here. We make sure that our line is parallel by making sure that it has the same slope. So this line, first thing I want to do is identify what the slope of it is. So y equals 3x plus 4. That's in slope-intercept form. That's in that y equals mx plus b. So when I see that 3 there attached to the x, that tells me that that is the slope of the line. Okay, that is the only thing I needed this line for. This is not the equation. We're not trying to make this point go into this at all. We just wanted to know, oh, this is this already existing line. We want to find out what its slope is, because then you and I are about to create our very own line with the same slope that'll guarantee that it's parallel. So our new line is going to have the same slope, but our line needs to pass through 1, negative 6. And really, after you've determined the slope of this other line, guys, you don't need it anymore. If you need to kind of cross it out and just get it out of your line of sight so you don't get it confused, you can do that. All we needed to know what was the slope of the line. And now with these ingredients, we'll create our own equation, right? I just needed to make sure it passes through 1, negative 6, and it has this matching slope so that when I create it, I know it'll be parallel. Okay. All right. And then really after you've determined this, guys, this becomes review. Okay. I've taught you 2 different ways to do this. The most recent one is point slope. So since I have the slope and a point that we want to make sure is on our line, we can jump in to point slope. So just a quick review here. This is point slope, and I can just insert our numbers where they go and then rewrite it in slope intercept, which is how we really like to see it. So let's go ahead and do that. So when I do y minus my y coordinate, that really becomes y plus 6. We want our slope to be 3, and then x minus the x coordinate, which is a 1. Okay. But then we agreed, unless the directions ask for point, we'll start with this, but then we'll move it. We'll move it into slope-intercept, which is our more common way of writing these lines. So once I've inserted these ingredients, these are the ingredients that are going to guarantee that these characteristics we wanted. By using this point, I'm going to guarantee that it passes through that point. By using a slope of 3, I'm going to guarantee that it's parallel to the one that was already established, right? So now we just do our 2 quick steps, right? Distribute the 3. And move the 6. And then those 2 quick steps, we are in slope intercept, and we have the new equation to our new line. So y equals 3x minus 9 would be what my new line would have to be. You know, when I look at it in comparison to this one, I can see, oh yeah, those would be parallel because they would have the same slope, different y-intercepts. And this one in particular would pass through 1, negative 6. It would pass through that point. So it meets all the criteria that I wanna have. Okay, so try it on number 8. Go ahead and try number 8 first, then you can unpause the video. All right, so check your work here. We've got y equals negative 3x, negative 3/4 x minus 5. That would be the equation of our line. So what I did is I took this one, which is currently in slope-intercept form. I was able to identify what its slope was, and then I used it for my new line. So my new line had to have the same matching slope so that they'll be parallel, but we want our line to pass through negative 8, 1. So that's the point that I used in my point slope. I inserted the slope, the y coordinate, the x coordinate, and then all I have to do is distribute and move the 1. This would be the equation of our new line. It would be guaranteed to be parallel to the original one here, and this one would pass through the desired point. Okay, we're going to do just one more of these, but this time what I want you to catch is the original line is not in slope-intercept. It is in point slope. It's in standard form. But we know how to find slope from there. We just basically need to find those intercepts. But we have 2 options. We can either find the intercepts and use the slope formula, or we could just solve for y. Both of those work. Okay, so you could either just reorganize this and solve it for y like we did earlier on these problems, or you could use the intercepts and then slope formula. I feel like reorganizing it, so that's what I'll do. I'm going to move the x term. So now I've got negative 6y is equal to x plus 12. And then I'll divide everything by negative 6. So this is all to reveal what the slope of this line is. And so when we do that, we get y isolated. We are now, same line, but we went from standard form to slope intercept, and now I can identify, oh yeah, I see it, the slope is negative 1/6. So the slope of this is negative 1/6, and then I can now proceed writing my own line. The rest of this now becomes just like what you practiced a minute ago. Our line, so I'm going to make myself a little border here. Our line is going to have a slope of negative 1/6, but it's going to pass through 3 comma negative 4. Okay, so then we'll write our equation. So we're going to do y plus 4 equals our slope of negative 1/6, and then x minus 3. We'll distribute to rewrite it in slope intercept. So that gives us negative 1/6 x, and a negative times a negative is a positive 3/6, which is 1/2, and then we'll just move the 4. So that gives us y equals, there's our slope, still matching, and then 1/2 and a negative 4, I'm going to subtract that, so that is going to be a negative 3.5 for my y-intercept. And that would be our equation of our line. It would be parallel to the original, but our line would pass through the point they asked us. Okay, so if we feel pretty good about that, you're definitely welcome to try number 10. I'm happy to check it in class, but I think we've got enough practice. Let's talk a little bit about then perpendicular slopes, and we'll finish off with this. So what's the difference here? Well, perpendicular lines, first of all, let's define them, and then we'll talk about what the relationship in their slopes is. When we're talking about perpendicular lines, what that really means is two lines that are still on the same plane, but they intersect to form a right angle. So they intersect at a perfect 90-degree corner, what you think of, what the perfect corner between two lines, 90 degrees, right angle. Okay, so when two lines intersect that way, they are said to be perpendicular. Okay, non-vertical lines are perpendicular if and only if their slopes are, and this is the biggie today, guys, this is the relationship in the slopes for perpendicular lines, opposite signs and reciprocal ratios. Okay, so opposite reciprocals. Opposite meaning the opposite sign, and you can see it right away here. If this line has a negative slope, the only way that I'm going to get a 90-degree angle is if the other one has a positive slope, or vice versa. If this is going upward, then the other one would have to be going downward. That's the only way you're going to be able to achieve that perfect right angle. So they have to have opposite signs, and then their rise over runs have to be reciprocals. So we reviewed that a little bit in our previous lesson, but reciprocal means we basically flip the numerator and the denominator. So here is a good example, right? This guy has a slope of 2, which is really 2 over 1, negative 2 over 1. So we would change the negative to a positive, and we would flip that 2 over 1 and rewrite it as 1 over 2. That relationship right there is what guarantees that the lines are perpendicular. Okay, so opposite signs and reciprocal ratios. So rise over run gets flipped. Okay, and when we do that, the symbol it looks like that. It looks like an upside down T, basically, capital T. Okay, so Let's do number 11. It says find the equation for a line perpendicular to the line shown in the graph that passes through the given point. So I have this current line right now. I want to create a new line, kind of like we did on the last couple of problems. I want to create a new line that is perpendicular to this guy but passes through -2, 0. So if you want, let's go ahead and even mark that right now. For sure we want our line to pass through -2, 0. So it's got to pass through that, okay? But I also need it to be exactly perpendicular. I need it to intersect this at exactly 90 degrees at a right angle. So to create that, that's where we're going to use those opposite reciprocal slopes. So step 1 is let's find out what this slope is for this line. Okay, so whether you use the graph or the slope formula, I'm going to realize here that this currently has a slope of down -2 and over +1, right? And so this current line, let's do that, that current line has a slope of -2 or -2 over 1 if you want to be really good about it, because we're about to flip that, right? So for our line, the one that we want to create, well, we want it to pass through -2, 0. And then our slope, though, it needs to be the opposite reciprocal of this. So if this was negative, our slope is going to be positive. If this is a 2 over a 1, then our slope is going to be a 1 over a 2. Okay, so the slope that we want is going to be a +1/2. And they did say find the equation, so we are going to write an equation here, and we'll also graph it in a moment so you can see it in action. But really the rest is like what we did. We have a point, we have a slope. We'll go ahead and drop that in to point slope. This is going to be -0, which ends up being equal, but I'll write it out. This is a 1/2. So this time I don't want the slopes to match. I want my slopes to be opposite reciprocals. So it'll look like this. I'll distribute, and that 0 will essentially disappear. I won't have to move it. So this is the equation of the line that I get. Okay, I'm about to graph that. And if I did it right, 2 things should happen. Number 1, it should pass through the point -2, 0. And number 2, it should definitely look like it makes a right angle with our current line. So let's find out. This line has a y-intercepted 1. And a slope of up 1 over 2. Up 1 over 2. And if we go ahead and, I can't find my, there's my straight edge. Okay. My line would look like this. And success. Absolutely, right? Definitely appears to be at that very nice right angle, 90-degree intersection, and it sure did pass exactly. When I did the y-intercept and slope, it did pass through that -2, 0 like we had hoped. So that is the equation of our line. Try number 12. Okay, so when you check this one, if you got y equals -1/3 x, then you're right on track. That should be the equation of our new line. So first things first, we determined the slope of the current line. So that was up 6 over 2, rise of 6 over 2, which is 3 over 1. And then we know that to create a perpendicular one, we will take the opposite reciprocal. So we'll switch the sign and we'll flip the fraction. And then it asked us for the equation to pass through -3, 1. So I made sure I used that point in my point slope. Distribute, move the 1, here we are. Okay, now, like I said before, if we graph this, it should do 2 things. Be perpendicular to this guy, and hopefully it's going to pass through -3, 1 if we did this correctly. So let's find out. I don't see a y-intercept here, which means it is 0. And the slope of -1/3 means go down 1 and over 3. Or up 3 and back. So as I graph this, my line should look like this. Okay. And then did it pass through -3, 1? Well, let's see. -3, 1 would be this point right up here, and it does, right? So 1, 2, 3 to the left and up. Oh, actually, should be more like at a 1. This is a 2. Maybe I made my angle. Is this going up by different things? It is. I should have paid attention to that. So this is going by 2. So really my point should have been more like here. So down 1 only halfway. Yes, yeah. Down 1 over 3 and up 1. So yeah, that was because I did not carefully look at the scaling. So be careful with that. So yeah, but it still passes through where it should, because boom, there it is. Okay, so this one, ignore the other one. This is going by 1s on one axis and by 2s on the other axis. That always makes it a little trickier. Okay, and really the graphing, guys, I'm really doing that to just show you that visual, but this is what you were tasked to do, right? It was all about writing the equation. So if you got here, you're good to go. The graph is just, you know, me giving you the visual aspect. Okay, determine whether 2 lines are perpendicular. Same thing. We're going to basically find the 3 slopes, and we're going to see if any of those are opposite reciprocals. We're no longer, if it's perpendicular, we're not looking for the same slope. We're looking for opposite reciprocal slopes. So let's do a couple, yeah, at least one of these. So for line A, I'm going to use the slope formula since we're dealing with 2 points here, just like we did before. So the change in my y's is 4 minus 1 over the change in my x's, 6 minus 4. So that's 3 over 2 for our slope of line A. For line B, that's going to be 3 minus 1 over 0 minus a negative is positive 2. So that is 2 over 2, which is a slope of 1. And then for line C, okay, so in line C, we're going to do 1 minus 3 over 4 minus 1. And that gives us a negative 2 over 3. And now that I know the 3 slopes, the idea here is, are any of these opposite reciprocals of each other? Opposite sign and the flip. And I want to recognize these 2 are, right? So I've got a positive 3 over 2 and a negative 2 over 3. And so I can say here that line A is perpendicular to line C. Okay. Try number 14. See if you can do it on your own. Okay, so on this one, B and C should be perpendicular. When you do the slope formula, you should get 3 over 1 for the slope of line A, 2 or 2 over 1 for the slope of line B, and negative 1/2 for the slope of line C. And so this one doesn't really have much in common, but these guys are exact opposite signs and reciprocals, so they would be perpendicular lines. Okay, one way to always check if you're not sure is if you multiply the 2 perpendicular slopes, they should always give you a product of -1. So when you multiply reciprocals, they basically should cancel each other and become a 1, and a positive times a negative is always a negative. So if you ever multiply opposite reciprocals, the product should be a -1, and that's another way you can check to see if you're not 100% sure. All right. So let's finish out here with writing a couple of lines, just creating lines that we can guarantee are perpendicular, kind of like we did with parallel lines. So on this last section, we want to write the equation of a line that will be perpendicular to this, but pass through the given point. So, you know, the majority of this is still going to be the same idea. We want to identify the slope of the current line, which in this case is 2/3. But this time, instead of using the same slope, because I would guarantee a parallel line, we want to make sure that our slope is the opposite reciprocal of that. So I see that this is a positive. I'm going to make mine a negative. I see that this is a 2 over 3. I'm going to make mine a 3 over 2. And that'll guarantee perpendicularity. And then the other thing that I want to confirm is that it passes through -2, +2. And once you set that up, guys, just like before, the rest is history. Throw that into point slope, which looks like this, just another reminder, and then simplify it out to slope intercept. So let's go ahead and insert what we know. So it should look like this when you insert the x, the y, and the m. And then in 2 quick steps, we should be able to get into slope-intercept. We'll distribute the slope. Like that. And then we will move the 2 so that y is by itself. And so when we do those, we should get y equals -3 over 2x. There's our slope, and -3 and +2 is a -1. So this would be the equation of our new line. That would be y equals 3 over 2x minus 1. That guarantees perpendicularity, and this point passes, or this line passes through that point. So we meet all of the criteria. Okay. If it's not already in slope-intercept, you may need to move things around so you can get there and see the slope. Okay, I'm going to pause the video here. I want you to try at least 1 or 2 of these and then check your answer. All right, so check your work here and hopefully you tried at least a couple of these. Number 16 should be y equals -1/2 x minus 1/2. For number 17, it's y equals 1/2 x minus 3. And for number 18, it's y equals -5 over 3x plus 10 and 1/3. So you can check the work here, see what it looks like, pick out the slope, create a opposite reciprocal, and use that and the point to rewrite your equation. Okay, all right, and then this last section, these are easy. We actually have done this before, so we'll be able to finish this in like 30 seconds. We've already talked about creating vertical and horizontal lines that pass through a point, and the big emphasis here is basically they are perpendicular to each other, right? All horizontal lines are perpendicular to all vertical lines. One's got that undefined slope, the other one has that 0 slope. They're always going to be perpendicular to one another. And so if I want the horizontal line that passes point, that horizontal line is just y equals whatever the y coordinate is. The vertical line that passes through this point would be x equals whatever that x coordinate is. Okay, and again, I showed this last time on the graph on our last notes, but basically this is what's happening. We have the point 3, -4, which let's say it's like maybe down here. So, or I should have this here. So -4 is the y coordinate, and this 3 is the x coordinate, and there's our ordered pair. And we're basically saying, hey, well, the vertical line that would pass through that would be the x equals 3 line, and the horizontal line that passes through that would also have the same y coordinate, would be the y equals -4 line. So it would look like that. Okay, and then that lets us fill in the rest of these really easily. So again, the horizontal here would be y equals 6. The vertical would be x equals 0 because those are the 2 coordinates. For number 21, the horizontal line would have y equals and then the same y coordinate, and the vertical would be x equals and then our x coordinate. And then last but not least, y equals 0 for this one because that's our y coordinate, and x equals 4. So those are that's basically this guy, right? So we've talked about this before. Hoi bucks. Right, so that's what's at play here, and those are always perpendicular to one another. All right, have a great rest of your weekend. See you Monday.